right? So here the next reaction is phenol on treatment with CH3Cl in the presence of AlCl3. This is our Friedel-Crafts reaction. Okay. So when we do Friedel-Crafts reaction, OH is ortho-para-directive. So the CH3 goes at the ortho position as well as CH3 goes at the para position. CH3 goes at the ortho position as well as CH3 goes at the para position. Now this is called orthocresol. This is called teracresol. Obviously, the para products are more major products. This is a major product and this is minor product. Okay, ma? This is a major and this is minor product. Okay, so this is how the reaction goes. The next one is, this is Friedel-Crafts reaction. This is Friedel-Crafts reaction. This Friedel-Crafts reaction. So this is how the reaction goes. Another reaction what we have to see is Kolb's reaction. Kolb's reaction. Generally, I see this Kolb's reaction is less asked in the examinations, but anyway, we have to know about it. So what is this Kolb's reaction? Phenol on treatment with CO2 and NaOH. CO2 and NaOH. So you get at 120 degrees centigrade, it forms a product of this kind. This is called sodium salicylate. Sodium salicylate. Sodium salicylate. And then sodium salicylate is a salt of salicylic acid. So we treat this with H3O plus to get salicylic acid. We treat this with H3O plus to get salicylic acid. This is salicylic. This is called 2-hydroxy benzoic acid. Benzoic acid. This is called salicylic acid. This is called salicylic acid.
Okay, sir.
Okay. Please note it. Once finished this, let me know. Next is preparation of aspirin. How do you prepare aspirin from salicylic acid? That will be the next question. Clear, right? This one. Can I clear, Amma?
Yes, sir.
Okay, fine. So this question may come: how do you prepare aspirin from salicylic acid? How do you prepare aspirin from salicylic acid? So the answer will be acetylation of acetylation of salicylic acid, gives aspirin. Use aspirin. Now, how do we do this? So, this is our salicylic acid. O COCH3 COOH. Okay, and now you have, yeah, that after that the product is you get CH3COH, so that you get this product CH3COH. Clear, right? So this is what is aspirin. That's what is aspirin. So because these are industrially important compounds, right? So they have, these reactions will be asked, high probability that these reactions will be asked in the exam. Amma, there is some question paper given to you in the KV, right? You are KV only, right?
Yes, sir.
There is some chemistry question paper I received from some other source
Yes,
on
sir.
KV. Yeah, okay, chemistry. So that I will try to make a video in this couple of days and I will post them up. Please go through that. Okay,
Okay, sir.
entire question paper I will discuss with answers, full answers. Go through that. That would be very important. I just made the notes in the past 2 days. So go through that. That is really important. That will be really good. Maybe like time taking like 1 hour or maybe more than maybe some 3-4 hours it may take. That full video with full explanation. Okay, ma'am. So please go through
Okay,
that. That I will post to you once it is over. Okay. Next,
okay.
can I clear this, Amma?
Yes, sir.
The next one is Raymer-Thyman reaction. What is Raymer-Thyman reaction? What is Raymer-Thyman reaction? It is called orthoformylation. Orthoformylation of phenols in the presence of CHCl3 chloroform and sodium hydroxide. Okay, chloroform and sodium hydroxide. So orthoformylation of phenols in the presence of CHCl3 and NaOH is called Raymer-Thyman reaction. This is the actual definition. So what is orthoformylation? It's a very specific word, orthoformylation. It refers to, orthoformylation means addition of CHO group to a phenol at the ortho position. So that is what is called Rhema time reaction. That is what is called ortho formulation. Ortho formulation meaning is addition of CH4 group to a phenol at the ortho position. So that is called ortho formulation.
Okay, sir.
Come on. Now the electrophile is dichlorocarbon. So these are like these points you have to remember. The dichlorocarbon is the electrophile. So this goes via electrophilic aromatic substitution reaction. So this reaction is actually reaction type is electrophilic aromatic substitution reaction. Electrophilic aromatic substitution type reaction. So that is the electrophile. Okay. Intermediate in this reaction.
Okay.
So what is the intermediate present in the reaction? It's called benzyl chloride. Benzyl chloride. The intermediate present in this reaction is called benzyl chloride. It looks like this. ONA, O minus, Na plus, and this CHCl2. This is what forms. This is the intermediate benzyl chloride. Okay, I'll redraw this. You can draw like this also, if you wish. So this is O minus Na plus, and here CHCl. This is the intermediate.
Okay.
Okay, right. Please note, we will go ahead next.
Yes, sir.
Okay. Now, how the reaction goes. So it's like phenol first on treatment with CHCl3, that is chloroform. The second one is NaOH. They treated with this. And then you get this intermediate benzyl chloride. This is our intermediate. Intermediate benzyl chloride. So this gets hydrolyzed. Benzyl chloride gets hydrolyzed. Gets hydrolyzed. Hydrolysis means these two chlorines are replaced by OH groups. Both these chlorines, both Cl2 are Cl groups. Okay, replaced by by OH groups. Both Cl groups are replaced by OH groups. So what do you get? You will get, in the presence of NaOH, this will happen. So you will get this one. So here you go, O minus Na plus, and simply CH. So you may be surprised how Cl2 is going to this. So I will explain in detail. This is the, and then this one will be treated with the acid wash. Acid wash is to remove the sodium plus. So you get the final product is salicylaldehyde. So that's 2-hydroxybenzaldehyde, that is salicylaldehyde.
Okay, sir.
So this is the product what you get. Okay, how this is converted to this? Okay, that we'll see now later once you know.
Noted, sir.
Okay, next. So how exactly this is getting converted? I'll let you. So here you go that you have this benzyl chloride is there. So here you have ClCl, and again you have this OH minus ions which are coming, right? OH minus will start hitting out this chlorine. Okay, another OH will come and it will hit this chlorine out. So like an SN2 reaction, it will happen. So when that hit the chlorides out, what you get is O minus Na plus, and then you get this one like this. This carbon will bear two OH groups. Always remember this. This is a very important point. Always two OH groups on one single carbon. Single carbon is unstable. Because it is unstable, H2O, water will be lost. Will be lost to give a keto group, a keto or aldehyde. Okay, aldehyde. So this is one important fundamental you have to know. So here, how the water will be lost? So HOH along with this, like this, it will be lost, and you can see that you have the water. Once it is lost, you will form this C double bond OH. So this is our salicylaldehyde. Cl minus salicylaldehyde. So that's the product. What you
Okay, sir.
next one is phenol. Phenol on treatment with zinc dust. This is one important conversion. When you heat phenol with zinc dust, you get benzene plus Zn. So phenol with zinc dust. This is the reaction of phenol with zinc dust. Zinc that will remove the oxygen and then gives benzene. And another reaction is oxidation of phenol. This is asked in the question paper. So when you take phenol and then to treat it with Na2Cr2O7 and again you heat it with H2SO4, you will get something called phenol. So it looks like this. So it looks like this. So this is benzophenol. This benzophenol plus H2. So let me make the O bigger. So this is the oxygen. This is another oxygen. Oxygen.
Okay, sir.
Now there are something called commercially important alcohols. Commercially important alcohols. What are these commercially important alcohols? They are, the first one is methanol. Methanol, which is CH3OH. That is methanol. So nowadays it's also called wood spirit. It is also called wood spirit. This kind of this 1 mark question, multiple choices it may come. So why it is called wood spirit is it is obtained by destructive distillation. Destructive distillation of wood. It is obtained by destructive distillation of wood. That's the reason it was called wood spirit. Can you clear, ma? Next part.
Yes, sir.
Nowadays, it is produced by catalytic. So this is a process of preparation of methanol. Preparation of methanol, that is CH3OH. A very useful product in the industry. Catalytic is done by catalytic hydrogenation. Catalytic hydrogenation of carbon monoxide of carbon monoxide at high pressure at high pressure and temperature at high pressure and temperature in the presence of in the presence of ZnO, zinc oxide and Cr2O3. This is important. This once it was asked, what is the catalyst used in preparation of CH3OH? That is zinc oxide and chromium oxide catalyst. So what do they do here is CO plus H2H2. 2H2. It is treated in the presence of this catalyst, ZnO and Cr2O3. This is the catalyst what they use. And now they create a pressure of 200 to 300 atmospheres. So that is a very high pressure. And now 575 to 673 Kelvin. 575 to 673 Kelvin. This temperature variations, you get CH3OH. This is called methanol or methyl alcohol. It is very industrially very much important reactions. That's why these are very important even for the exam. Industrially, look for the reactions which are industrially very important. Those are the things which are prone to come for the examination. So please look in that direction, man. So anyway, I will discuss those things.
Okay, sir.
Now the properties like if CH3OH is a colorless liquid. Its boiling point is very, very low. It's about 337 Kelvin. And highly poisonous. It's highly poisonous. So we have to be careful with this one. Small quantities can cause blindness, and then large quantities can kill us also. Okay. So uses wise, it is used as solvent in paints. Used as solvent in paints. Used as solvent in paints, varnishes, and preparation of formaldehyde. Preparation of formaldehyde. And it can be used as an antioxidant. And which is this one, it can be used as antioxidant. So you may ask me what is the use of formaldehyde? How industrial important I will tell you. There was the situation, it was late 1960s around in history. There was, I don't know who has done, I think it was the Americans, I think, Americans only. They want to create a bio weapon. So for the bio weapon, they have chosen some islands where they produced these bacteria like anthrax and other stuff. And at certain point of time, it went out of their control. The bacteria, what has developed, bacteria and viruses, what has developed on that particular island, it went beyond their control. So they could not control that, and they left that islands and they went off. After that, I think this is very recently they have done. I think I read it on Google somewhere. It's few years back only. What they have done was they have taken helicopters and they have gone to these islands because they want to re-inhabit that islands. So they have taken the helicopters, and in the helicopters they have way they have taken this formaldehyde and formic acid mixture. I think this they have taken and they have sprinkled this entire formaldehyde all over the island and ensured the complete sanitization of the island. That much powerful is this formaldehyde. It can kill any kind of germ or it can kill any kind of virus. It is that kind of thing. In fact, if you want to save some this like some of the organs, like in biologists, they save these organs inside this formaldehyde. What we see in some kind of
Okay.
movies. So that's the use of formaldehyde. But the red ants will have this formic acid within its body. So when the ant bites, we'll get a lot of pain over there because of this reason. And here in our around our place, we find this fire ants, right? Red color ants, very somewhat bigger ants, And this I saw at the Tirukkalkundram temple. Once I went to Tirukkalkundram temple. This that DT, the god is in the hilltop, right? That there I went. So when I went there, that one red ant just it has bitten me on my hand. I still remember that sting. My hand was like it was like 2-3 ants. I think they have bitten my hand, but my hand is unable to. I am unable to move my fingers. That much it has swollen, and then the nerve, the complete nerve, wherever it has bitten me, that nerve has actually swollen to that extent. So that injects that much heavy amount of formic acid inside the body. So that red ants, if there is a large number, we will even die with that stings. that level they are. So they
Yes,
are tyrants. You might be
yes,
knowing about that. Okay. So that
yes,
contains
sir.
a humongous amount of formaldehyde. Humongous amount of formaldehyde. Now we have the next one is
Yes, sir.
ethanol. We have to see, and this is well-known thing everywhere. Government is running because of this, right? C2H5O. Brandy, whiskey, whatever you want to call, belt shop, whatever you want to call, this is the one which is generating income for the, in fact, world itself. India, that every night this is the product. So what do they do? It is obtained by fermentation of. It is obtained by This is industrially important. It obtained by fermentation of fermentation of sugar present in molasses. Sugar cane and or fruits like grapes or fruits like grapes. So this is normally this from grapes. They get this wine. This is called from grapes in Kerala. Generally, they will make. Okay, if you know this from grapes, this especially black ones. Okay, the black grapes they will take and then they will make this red wine out of it. So this contains a very good percentage of alcohol. So what do they do is they will take this process. I came to know from one of my friend. They she told me actually that you had to put the grapes like this and then pour sugar over this. Sprinkle sugar over this, and again grapes over this, and again you have to sprinkle sugar over this, and this all the things set up have to be placed like layers. How many layers you can put, that much you will get. That is for sure. So all this setup you had to put it inside a cooker, and now in the cooker, okay, pressure cooker, they will just allow it to heat. They will heat it and they will simply heat it for long hours. I think I don't know how many whistles you have to get. It's like some. She told me that some this many whistles you have to get, and then this is very traditional at our home. This is what she was telling, and she was drinking that one day when I saw her. So I asked her, what is that red thing? She said red wine. This is very traditional to us, she told. Okay, how do you prepare? I asked that. So because we are in chemistry, no, so it's like I, out of curiosity, I just happened to ask her. She told this is the
Okay.
methodology you have to do, and then put the grapes over that once again, and then heat it, and then heat, and then get some as many whistles as you can. And after that, you had to leave it for, she told, like 40 days you had to leave as is. You don't open that and then leave it for 40 days.
What is it?
So that,
Oh,
that's a beauty. 40
okay.
days if you leave, what happens is the bacteria inside this will be this sugar and the grapes and the bacteria, whatever is that, it will turn this entire grape juice into red wine. The more the days you leave, the more the percentage
Okay.
alcohol you will get. So that's what she told me. So that's the same
Oh,
process almost like they will follow in every industry to produce this alcohol, ethyl alcohol. So what is this molasses? Molasses is
okay.
the waste what you get out of this while extraction of sugar. This is molasses is what you get. Okay, so that's the base what you obtain. So the reaction wise, it is like C12H22O11. This is the sugar and water. In the presence of water, the bacteria they will use some. They will release some enzyme called invertase. Invertase, and that forms C6H12O6 plus C6H12O6. One is glucose, another one is fructose. Glucose and fructose. These two you need. And now this glucose or fructose. C6H12O6. This is the glucose or fructose. Glucose or fructose. So it is done by bacteria and other microbes, and they release another enzyme called zymase. Zymase. So you get this zymase will make the C2H5OH. It will break these sugars, and again they will release 2CO2. And this CO2 along this mixture will cause that rotten, horrible smell actually. So when I actually pass to my hometown Vijayawada, there is one factory, liquor factory. When the bus passes by that, we have to close our mouth, nose, everything, whatever is there around. Okay, windows, doors, everything.
Yes.
You cannot pass by. That much horrible smell it will generate because of one is the CO2. The CO2 will carry that smell. Tremendous release of CO2 will be there. Carbon dioxide will be there, and the carbon dioxide will carry that horrible rotten smell. Okay, because of this waste. So this.
Okay.
So this is the condition. Okay, we'll talk about fermentation in the later. I think your class. I think you had to go to school now, right? Hello, ma. Do we
Today
have
I'm
time?
not going, sir.
Sorry, ma.
Today I'm not going, sir.
Okay, ma. Then fine. We'll continue then. So fermentation takes place. So here we go. So the fermentation. So this is the reactions. Okay, please note this reactions.
Noted, sir.
Okay.
Mm.
Now fermentation takes place in anaerobic conditions. In anaerobic conditions. In anaerobic conditions. That is in the absence of air. In the absence of air. So that's why this is the reason why she is not. She didn't. She told that she has to leave that cooker for 40 days without opening. So the fresh
Yes,
air
sir.
will not come into the picture. This is the reason fermentation takes place in anaerobic conditions in the absence of air. That's one thing.
Yes. Okay,
Carbon
sir.
dioxide is released during this process. CO2 is released during this process. CO2 is released during this process. If air gets into fermentation mixture, the oxygen in air, the oxygen in air oxidizes ethanol to ethanoic acid. Ethanoic acid. Ethanol to ethanoic acid, which destroys the taste, which destroys the taste of alcoholic drinks. Alcoholic drinks. So these are the things what we have to know. So these two, especially the invertase and zymase role, is most important. Invertase breaks the sugar into glucose and fructose, and
Okay.
zymase makes the alcohol to form. So these two roles you have to remember. Rest of the things are over. So this is where we'll close today, ma. So we will see the next class. Next class tomorrow. Is that okay to have tomorrow at the same time?
Tomorrow.
Yes, ma'am.
Okay, sir.
Okay, ma'am. Same time we'll meet tomorrow. Maybe you may have to go to school, so I will leave at the same time. No issues.
Okay, sir.
This is sufficient. The 15 minutes sufficient to go to school, right? I hope nearby.
Yes, sir. Okay.
Okay, ma'am. Right. Tomorrow we'll meet at the same time. Okay, fine.
Okay.
Bye.